Congratulations! This live broadcast is specially brought to you by Academy YouTuber Malaysia, an initiative by EDD Malaysia and Kelab Guru Malaysia. Please pay attention. The live broadcast will begin shortly. The link to the certificate of attendance will be provided at the end of the session. Please make sure it is filled within the stipulated time. Thank you.
Moderator. Moderator.
Sorry.
Suara.
Okay, Assalamualaikum warahmatullahi ta'ala wabarakatuh and good evening. Hi, all teachers, parents and wonderful students. Welcome to Pusat Tuisyen Academy YouTuber, a joint venture with EDD Malaysia and Kelab Guru Malaysia with the hashtag bermula percuma, selamanya percuma. Before we proceed, let's begin our session with recitation of Kitab Al-Fatihah for the Muslim and for the non-Muslim, a moment of silence. Al-Fatihah. So how's everyone today? My prayer that everyone is in the best of health and ready to proceed with today's class. Before we start, let me introduce myself first. My name is Nun binti Muhammad Noh. You can call me Madam Nun and I am your moderator for today's class. I am a lecturer at College Matrikulasi Negeri Sembilan Kuala Pilah. Together with us today is teacher Hafsah AYU as our host controller from SMK Sultan Sulaiman Kuala Terengganu and our observer teacher Im from College Tingkatan 6 Tapah Perak. All of us here are to ensure that our today's session running smoothly. And the most important person today is our passionate and fantastic presenter, Madam Rosmaya. She is a very experienced teacher from SMJK Yuhua Kajang Selangor. So let us give a warm welcome to our presenter. For the record, we are now live in Madam Rosmaya channel. So as a sign of support to Madam Rosmaya for the hard work in preparing today's lesson, please subscribe her channel and all of you can visit also channel teacher Im, teacher Habsahayu to get a lot of learning material and not forgetting to subscribe their channel too. So as usual, the lesson will last approximately 1 hour. The certificate link and the credit claim link will be given at the end of this session. Remember that you can only use EDD email to claim the certificate. For credit claim, you need to collect the 1 letter and 4-digit code, which will be announced separately during our class today. So be sure to follow the class up until the end to get the complete code for the credit claim. I would like to remind students to use appropriate language and use appropriate profile picture if you wish to post comment in the chat box. I am pretty sure all students here are excellent students who will uphold a positive classroom environment. Please give your full cooperation in making this class a lively one. Stay focused, and if you have any question, please write on the chat box and we will try to provide you the answer. Before I give Madam Rosmaya to present, I announce the first digit code for the credit claim. So make sure that you write down somewhere. So the first digit code is A7. Okay? A7. So without further ado, please welcome Madam Rosmaya to start her presentation. Okay, Madam Rosmaya. Thank you.
Okay, hi everyone. I am Madam Rosmaya. I'm a physics teacher from SMJK Yuhua Kajang Selangor. Okay, welcome to physics class today everyone. So before we start, okay, thank you to our moderator. Thank you to our moderator. So I would like to announce something. Okay, maybe some of you didn't know about this. Okay, so actually the Academy YouTuber has the Google has apps already. You can download here. You can get the apps Academy YouTuber. Okay, from the Google Play Store. From the Google Play Store, and download from there. Okay, we have a lot of you can get a lot of tuition free live dev and other PDPC videos, okay, from the apps, okay. So including the past live class, okay. So all can get just using touch from your hand onto your phone, okay. Okay, so I'm also going to introduce the pre-U teams in Academy YouTuber, okay, the collaboration team from STPM and matriculation. So
Maya, you
yeah.
have not shared your screen.
Oh, where is? Oh, sorry. Okay, thank you, Teacher Im, for telling me. Okay, so I go back to this one. This one. Okay, so you can get the apps from Google Play Store. Okay, to download the apps Academy YouTuber to get all the videos from there. Okay. So the pre-U teams in Academy YouTuber, we have here today with okay. First of all, the physics team led by me. Okay, I am Madam Rosmaya, and together with us is Madam Non. Okay, Madam Hapsayu. Okay, these two teachers are from physics. Okay, physics. Teacher Non is from matriculation, and Teacher Hapsayu is from STPM teachers. And we also have together with us Teacher Im. Okay, Teacher Im on top of me. Okay, she is a Maths teacher. Okay, STPM teacher. Okay, so not with us is Teacher Su and Teacher Suhaya. Teacher Suhaya from matriculation. Okay, so other team is Teacher Im teams. Okay, lead by this is Maths team. Lead by Teacher Im together with us on top of me. Teacher Im. We also have biology teams lead by Cikgu Faiza. Okay, we also have chemistry team lead by Cikgu Shahnon. And perakaunan and economy, okay, matriculation team, okay, lead by Madam Fizi. And also other STPM subject, pengajian MURID, pengajian perniagaan, perakaunan, okay, also in the pre-U Academy YouTuber team. Okay, so now today's discussion. Okay, what is today's discussion? Okay, today's discussion is on center of mass. Okay, center of mass. So what is center of mass? What is center of mass? Okay, center of mass is the center of mass of a rigid body is defined as the point where the whole mass of the body is assumed to be concentrated. Okay, so the principle of center of mass usually we use in balancing, balance to keep things balanced, to keep object balance. If we throw the object here, let's example here the bed. Okay, so to look to observe the object here thrown projected from here in a projectile path. So you can join all the center of mass so you can see the projectile path clearly. Okay. I'm sure you all can do this simple experiment to get the center of mass of the two objects here, the spoon here. Okay, you can Google and search how to do this simple experiment. Okay, this one also can be done very easily. You balance the ruler here. Okay, it can be balanced to stay horizontally when you put your finger at the center of mass. So the center of mass has a lots of use, actually a lot of use. So this is one of the use to keep the object in balance. Okay, so for our topic today, okay, so we discuss the center of mass, okay, for the uniform object, for the uniform object. So if the body is has uniform density, center of mass will be located at the centroid, centroid. For example, here, this is a rectangle, okay, rectangle, or can be cuboid, or cubic. So to determine the center of mass, we just do a diagonal line here. The intersection point will be the center of mass. So this is for uniform body. So it's very easy to determine the center of mass. Okay, I can see there, Pak Lishan. Okay, good day to you too, Pak Lishan. Okay, so next, the circle, the sphere or the disc, for example, the disc or the sphere. So the center of mass is located at the center of the circle here. If this is a disc, if it is a sphere, so in the middle of the sphere. Okay, another one is the triangle here. So the center of mass can be determined by just drawing a line here. Okay, bisect this line. Okay, so joining all this line, these three lines, so the intersection point here will be the center of mass. So this is how to determine the center of mass for the uniform object, like these three objects. Okay, for the mass, sometimes center of mass does not lie on the object itself. It may located outside the physical body. Example, in the case here, the hollow object here, for example, like ring or donut, any donut shape object. Okay, so the center of mass lies in the middle here. So it does not lie on the object itself. Another example is the L shape here. So the center of mass lie outside here, somewhere here. Okay, so in the case of distribution of separate bodies, okay, such as the planets of the solar system, okay, center of mass may not correspond to the position of any individual member of the system. For example, here Earth-Moon system, okay. So the center of mass is somewhere there. You can see the cross there, right? So that's the center of mass. So we can use a formula to determine the center of mass here. Okay. So if you draw the Earth's rotation here, okay. Example, the planet here is the Earth and the Moon. Okay. So the center of mass will be the this is the coaxial orbit. So the center of mass will be in the middle. Okay, at the center of the circle. Okay, so for the system that consists of n particles of masses, okay, M1, M2, M3, and Mn, okay, n particles. So the points of coordinates, we can draw a Cartesian plane and name the point as x1, y1, x2, y2, and so on. Okay, xn, yn. So the coordinate of the center of mass are given by, we use this symbol for the center of mass, bar x, bar y. Okay, or you can use also min x, min y. Okay, so the bar x is given by m1 x1 plus m2 x2 plus ... Okay, depends on how many particles, divided by total of their masses. Okay, so in mathematical form, we can write like this, use summation symbol. Okay, for the bar y, okay, the same thing, but we use coordinate y instead, m1 y1 plus m2 y2 plus ... m n y m depends on the n particles divided by total of their masses. Okay, so now let's try a question. So how to use this equation. Okay. Okay, example. Let's say we have these three objects. These three objects. Okay, this object, the mass is 2 kilogram and it is located at the point 2, 3 on the Cartesian plane we choose. You can choose anywhere actually, the Cartesian plane. So the origin will be a fixed point. So we measure the distance, all this x and y from the origin here. Okay, so the coordinate for this 2 kilogram object is 2, 3. Yeah. So another one is 5 kg. Okay, we put here. So the coordinate will be for -1 because we choose here as the origin. So the coordinate here will be for -1. And the third object, let's say 3 kilogram. So the coordinate will be 5, 6. So very easy actually to use this equation. So we just put all the message. This is 3 object, right? So we have 3 terms here. Okay, 3 terms. So we substitute their mass. Okay, their masses. So 2, 3, and 5 kg. And then the total of mass at the denominator here. So 2 plus 3 plus 5. Okay, then the 2 kg distance from the fixed point here 0. Okay, for x, x value is 2. Okay, and then for the 3 kg is 5. And for the 5 kg, it is 4. Okay, so you just calculate it. So you get the value. For the y bar, we do the same. But this time, we substitute the coordinate y. So for 2 kilogram, okay, you times the 3. For 3 kilogram, you times 4. And the 5 kilogram, you times -1. So you must bring along the negative. Okay, bring along the negative. Okay, because we use the fixed, the Cartesian plane we choose is here. So this is the origin. So that's why it has negative here 1. Okay, so now the both value we get is bar x is 3.9 and bar y is 1.9. So where is the center of mass? So we can mark here on the Cartesian plane here we've drawn. So somewhere there. Okay, this is where the center of mass is. Okay, very easy, right? So next we try the first question. Just now is the example. So the first question, we can, I given already in the description part. Okay, given already in the description part. So hopefully you've download the questions and do. And if you got the answer, you can write there in the chat box. You can write there in the chat box. Anyone who've done, you can write there in the chat box. Okay, so we read the question first. Okay, 3 particles of masses 50 gram and then 100 gram and 150 gram. Okay, are placed at the vertices of an equilateral triangle. Okay, of side 1 meter as shown in the figure below. So 1 meter, all the sides. So the coordinates of the center of mass will be, okay, anyone have done? Because I given already early this morning. So those who have done can write there in the chat box. So for this question, we do together. If you got the same answer as me, you can also write there in the chat box. Okay, so for the equilateral triangle, okay, we know that the angle in the between the two sides here is 60 degrees. Okay, 60 degrees. So you can determine the point. Okay, for the 50 gram, the coordinate will be 0, 0 because it lies at the origin here. Coordinate for the 100 gram will be 1.0 and 0. And lastly, for 150 gram, okay, so you can use the trigonometric ratio to determine the y distance, y1. For the x-axis, for the x coordinate will be 0.5 because 1 here, right? So the middle here will be 0.5. So for y1, you can use trigonometric ratio. So let's say we use tangent. We use tangent 60 degrees. So opposite will be y1 divided by the adjacent 0.5. So you get y1 0.866. Okay, so that's how we get the coordinate. So after you've done all the coordinate, then we can use the formula just now. Okay, so did you all memorize the formula? So this is the formula for the bar x and bar y for the center of mass. So for bar x, we do bar x first. Okay, we have how many objects here? We have 3 objects. We have 3 objects. So that's mean we must have 3 terms here. 3 terms here. Okay, so the mass will be 50 gram and then 100 gram and 150 gram. And down here at the denominator here is the total of their masses. Okay, for 50 mass, it lies on the origin. It lies on the origin. So it's 0. 50 times 0. So 100 gram, okay, the x distance from the origin is 1.0. And for 150 gram, okay, the x coordinate or distance from the origin here horizontally is 0.5. Okay. Okay, so we get 0.58. So did you all get the same answer as me? You can write there. At least I know someone joined with us today, physics class today. So let me know. Okay, so we
Okay,
try.
Madam Rosmaya,
Yeah.
can I announce the second digit code
Okay,
for a
okay.
while? Okay. So hi student, our second digit code is 7. Okay? Our second digit code is 7, so make sure that you write down somewhere. Thank you. Okay, you can continue, Madam Rosmaya.
Okay, so continue with bar Y. Okay, bar Y. Okay, for bar Y, the mass 150 gram, 100 gram, and 150 gram. So the total of mass below here is 50 plus 100 plus 150. So the Y coordinate will be for 50, it lies on the origin. So the Y coordinate here 0. And for 100 gram also, Y coordinate is 0. And for 150 gram, okay, the Y coordinate we calculate using trigonometric just now. Y1 is 0.866. Okay. So the answer is 0.43. So C is the answer. Okay. So those who get same answer with me can just write there. Or you don't have time to do. It's okay. So we continue with the next question. We continue with the next question. Okay, so we read the question first. The masses of the Earth and the Moon are 6.0 times 10 to the power of 24 kilogram. Okay, and 7.4 times 10 to the power of 22 kilogram respectively. So the distance between the Moon and the Earth is 3.8 times 10 to the power of 8 meter. So determine the position of the center of mass of the Earth-Moon system. Okay, where is the center of mass? So we use the same concept. Okay, first step, choose the Cartesian, draw the Cartesian plane. So the fixed point or the origin can draw anywhere actually, but choose the easiest one. The easiest one, so the easiest one is we choose here, where the Earth itself lies on the origin. Okay, there's a reason. You can use at the Moon as the origin also. Can anywhere you can choose, but choose the easiest one. Finally, you will get the same answer. So now let's choose the origin at the Moon, at the Earth here. At the Earth here. Okay, so we choose here. Why? Because we only need to calculate the bar X. No need to calculate for bar Y because the Earth and the Moon here lies horizontally. Okay, in one line along X-axis. Another word along X-axis. So we don't need to bother about Y-axis. Okay. Okay, so now we substitute. We have two object only, Earth and Moon. Okay, so that means we have two terms here, and the mass of the we substitute the mass of the Earth and the mass of the Moon into the equation, and the total. Okay, then the distance. Okay, the Earth itself is lies on the origin, so therefore times 0. So the Moon lies, okay, from the origin here is 3.8 times 10 to the power of 8. Okay, so we can get the answer already, right? Very, very easy, right? Okay, so the answer is 4.6 times 10 to the power of 6 meter. Okay, very large value. Okay, so who get answer same as with me? Same as me? Can just write there in the check box there. Okay, so now where does this point lies? Sometimes question ask you to mark on the diagram. So let's look. You must to mark. You must know the radius of the Earth. Okay, so radius of the Earth is about 6.4 times 10 to the power of 6 meter. Okay, 6.4 times 10 to the power of 6 meter. Now compare with this center of mass. 4.6 times 10 to the power of 6 meters. So it less than the radius of the Earth. So that means center of mass lies on the object itself, on the Earth, on the Earth, and along the X. So somewhere there. Can see or not the blinking yellow circle there. Yeah, somewhere there. Okay, not necessary to be accurate, but we can just guess it. So this is 6.4, so 4.6 somewhere there. Okay, so from the top view, okay, if you observe from top view of the Earth Moon system rotating, so that's why when the what you call this moon rotating the Earth, okay, orbiting the Earth. So the Earth also is rotating at the center of mass there. Can see or not? So the cross there. This is from top view. We look from here. So they are move in a orbit. So that is where the fixed point is. Center of mass is the point where the object means fixed, stationary, doesn't move, doesn't rotate at all. Only the other particles on the object itself rotating or orbiting. Okay, so we go to the next question, and if you don't understand, you can just write there in the chat box, so that I can see whether you got problems or not. So if nothing written there, I assume that you all okay with the question. Okay, so we go to the okay, now you see if I draw the orbit the path of their circular motion, okay, the circular motion path, you can see so the two circular path here is sharing the same center, they are coaxial, right? The two circles are coaxial, so they share same center. Okay, so we go to the next question, question 3. Okay, question 3. We have 3 blocks here, 3 blocks. So we are going to find the mass, the center of mass of the blocks. Okay, so the blocks are the same, the similar block. Okay, the same block, and the length, their length is L, and the width of the block is L per 2. Okay. So the block actually got what you call that length, width, length, height, and width, right? Length, height, and width. So we can ignore the width because all of them have same width. Same width. Okay. So first step, you draw a Cartesian plane. Okay, you draw a Cartesian plane. So let's choose the Cartesian plane. Here is the origin. Okay. Then we find the center of mass individually for each object. So this is a rectangle. So that means center of mass for this object alone is in the middle here. And you draw the diagonal line. Okay, here. So the intersection point will be the center of mass for this object alone. Okay, so same goes to two other object. There, the center of mass for the second object, and the top object center block. The center of mass there lies there. Okay, so now we write the coordinate. Okay, next step we write the coordinate of the object here. So the coordinate will be okay. The length of the object, the block is L. So that means the x coordinate will be L per y. And for the y coordinate, okay, this is L per 2. The height of the object is L per 2. So divided by 2, we get L per 4. Okay, not? So this is the coordinate for first object. So second object, on top of this one, you do the same. The coordinate will be, okay, L per 2 plus another L per 4. Okay, L per 2 plus L per 4, we get 3 L per 4. And then the distance, horizontal distance from the fixed point will be L. Okay, so it equals the length of the object. Okay or not? Can you all see? So L here and 3L per 4. And the last one will be, okay, L per 2, L per 2 plus L per 4. So this part L per 4 plus L per 2. So we get 3L per 4 for X coordinate. And for the Y coordinate, okay, so we have 2 blocks here. So L per 2 plus L per 2, 1. And then we have another 1 per 4 here because L per 2 divided by 2, L per 4. So we get 1 per 4 becomes 5L per 4. So after get all the coordinates, then it will be easier for you all to use them to substitute into the equation. So the equation for the coordinate, the equation for the center of mass, okay, this one, total of product of mass times x. X is distance from the fixed point divided by total of mass. Okay, so now we have 3 blocks. Make sure you have 3 terms so that you won't make careless mistake. Sometimes we make careless mistake, right, in the exam. So by doing like this, you will be reduce your careless mistake. So we have 3 blocks, 3 objects. So that means 3 terms here. Okay, so mass of the block is not given, right? But they all have same mass. They all same block, so means same mass. So we can just substitute m into here because later we can cancel out this m. And the total of m will be m plus m plus m. Okay, right? Okay, so m can be cancelled out. Okay, then the distance for the first one, this one, the distance we use substitute L per 2, all the x coordinate, L per 2 and then L, and the top blocks is 3L per 4. Okay, now we simplify. So m plus m plus m, 3m, this one also we get the in terms of m, and we can cancel out m. So we don't use at all the m here. So the coordinate of the center of mass for x is 3L per 4. Okay, next we calculate the y, bar y. Okay, for bar y, so we use the y coordinate. Okay, so we substitute all the m here. Same block, so same mass, all m. And the distance from the fixed point for first block, L per 4. And for the second block, 3L per 4. And for the top is 5L per 4. And we get the answer 3L per 4. So we can guess where is it? Where the center of mass is. So 3L per 4, somewhere here. Okay. And 3L per 4, 3L per 4. Okay, same. 3L per 4, 3L per 4. So it's somewhere there, somewhere here. Okay, done for question 3. Okay.
Okay, Madam Rosmaya, you want to take a break for a while for the advertisement?
Okay.
So, okay everyone, let's watch the advertisement.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata gancaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus gancaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay, Madam Rosmaya, I want to announce the third digit code. Okay, so student, please listen carefully. Our third digit code for today's class is 4. Okay, 4. So, Madam Rosmaya, you can proceed with the presentation. Thank you.
Okay, welcome back everyone. So remember the code number 4. Okay, jot that down for the credit claim. Okay, so next question is question 4. Okay, so we read first the question. The figure below shows a uniform metal plate which is made up of a square of sides 20 centimeter and an equilateral triangle. Okay, so joining together here. So find the center of mass of the metal plate, the metal plate below. Okay, so we first step, we choose the Cartesian plane, the Cartesian plane where the origin will be here. Actually, you can draw anywhere along here. Okay, choose the easiest one, but I choose it here. So we do together here. You can try later on the other, or if you've done it, you can compare with my answer. Surely you get the same answer. Okay, next is the find the center of mass for individual combination. Okay, this plate is combination of two. Okay, combination of metal square plate and also the triangle plate. So we separate them. Okay, separate them. So we find the center of mass individually. Okay, so for the square here, so you draw the cross, okay, diagonal, and you get the center of mass, okay, there. Okay, then you find the distance from the origin of the Cartesian plane just now. Okay, so the x here will be, okay, the square is 20 sides, okay, 20 sides. So that's mean 10 here plus another, the height of the triangle here. So what is this height? So you can calculate using Pythagoras theorem to get this height. Okay, we have equilateral triangle, so that's mean the side is 20, okay, 20 cm, and the 10 cm divide by 2, so we have 10 cm. Okay, so we take out the part of the triangle here just to show you the Pythagoras theorem. So that's mean the height of the triangle will be 17.32 centimeter. Okay, 17.32 centimeter. So that's mean the distance of the square here from the origin will be 10 plus this 17.32. Okay, so total them up, you get 27.32 centimeter. So this is the distance of the square from the origin. Okay, next is the triangle. Okay, this triangle. So this triangle, the center of mass of this equilateral triangles, you draw the, what you call this, the line, bisect this, the opposite line from this vertex. Okay, so you draw another one, and the intersection point will give you the center of mass. Okay, so the center of mass here, you can prove using maths. You've learned this already, right, in the secondary school. Okay, so this point is actually 2/3 of the height of the triangle here. Okay, measured from the origin here. So it's 2/3 of the 17.32. You can prove this using the maths, but I don't want to go through that. You've learned in maths already. So you just take the formula. Okay, it's 2/3 of the height of the triangle here. So that's the center of the equilateral triangle. So 2/3 times 17.32, you get 11.55 centimeter. Okay, so after you get the distance x, now we can substitute into the formula of the center of mass. So the total of mass times distance divided by total of all the masses of the object. Okay, we have two objects. Just now we divide into two, square and the equilateral triangle. So that's mean we have two objects. Okay, next, mass is not given here. Okay, mass is not given here, but we can use the formula for mass, density times volume. Okay, so density is mass per volume, so mass is density times volume. Okay, so the density times the volume will be the cross-sectional area times the thickness of the plate. Okay, thickness of, because this is the plate, so thickness of the plate will be constant, density also constant because they are same plate. Okay, they are same plate, so that means M is directly proportional to A. Okay, so if M is directly proportional to A, so it doesn't matter if you use M as A. Okay, we can replace A into here, into the M. Okay, substitute A into the M here because M is directly proportional to A. Okay, so now we use A instead. No need M. Because M will be different, not like just the block just now. The block we discussed in the previous question, the block all has same mass. But this time, the square and the equilateral triangle here doesn't have same mass. So you cannot substitute mass here. Okay, so you substitute area instead, cross-sectional area. Okay, so now you substitute the cross-sectional area. So 20 times 20 for the square. Okay, and for the triangle will be half time base 20 times the height 17.32. Okay, in the chat box there I can see Cikgu Faiza. Okay, welcome Cikgu Faiza to the physics class. Thank you for joining us. Okay, so we continue with our calculation here. Okay, so the total of mass, instead we use total of area. So 20 times 20 plus area of the triangle, half time base times height. So the base of the triangle is 20 and the height is 17.32. Okay, now the distance from the fixed point, the origin of the Cartesian plane you've drawn, is 27.32. Okay, calculated this now. And for the equilateral triangle, so the distance from the center of mass of the equilateral triangle is 11.55. Okay or not? So we calculate all these and we get 22.6 cm. And this 22.6 cm is measured from the origin from the Cartesian plane that we chose just now. Okay. If you draw different position of Cartesian plane, so that's mean your measurement and your center of mass will measured from that value, from that origin. So now this 22.6 measured from the origin of the Cartesian plane here, I drawn this now. So it's about 22.6. So must be, it lies in between here, the center of the square, because the center of square is 27, right? 7.32. So it lies here, and the triangle here is 17.3. So in the middle here. So this is where center of mass is. Sometimes in the exam, they ask you to mark. So you must be able to mark also. Okay, make sure it's logic. Where you mark must be logic. So somewhere there. Okay or not? So if got any problem, you can write there in the chat box. Because I can read there in the comment. I can, so that I can help you where you don't understand. Looks like no comment there. Okay, so we go to the next question. Okay, so now the questions become harder and harder. So the questions become harder and harder. So we go to the next question. Question 5. Okay, a small disc of radius half r. So the radius of this disc is half r. Is removed from a disc of radius r. Or here, this one. This is a big disc. So this is a small disc. Okay, it's removed. And the small disc is half r. Okay. So find the center of mass of the remaining portion of the disc. Okay, so the blue disc, cut the small circle, this is cut from here. So what is the new center of mass? Before it is cut, the center of mass is in the middle, right? In the middle here. Okay, so what to do? From the equation, from the equation here, so just like just now, question 4, just like the question 4, mass is not given, mass of the this here. So we can use area instead, because it's the same this, same this. Why? I repeat again, because mass is density times volume. Okay, so density is the same because the this is cut from the same this. So density, both of them is the same. So volume is cross-sectional area times thickness. So we can use the cross-sectional area. Thickness is the same because this is a disc. This is a disc. So the thickness is the same. So therefore, we can use A instead of M, because M is directly proportional to A. Okay, when M increases, A also increases. So we can substitute A into the equation here for M. Okay, so now, next step, after you draw the Cartesian plane, okay, the Cartesian plane, you can choose anywhere, but choose the easiest one. So I choose at the center of the big this, the big this is easier to solve. So I choose it here. So therefore, for the small disc, the center of the mass will be in the middle of the disc. For the big disc will be here. Okay. So second step, you determine the center of mass individually for individual object. Okay, so next, there are two objects. We consider as two objects, the small disc and the big disc. Okay, so we have two terms here, small disc and the big disc. Okay, now we substitute the area. For the big disc, the area is pi r squared. Okay, given r, right? Big capital letter R. So pi r squared. For the small disc will be pi half r, half r squared, bracket half r squared. And it is negative because we take it out. Okay, it what you call this? It's removed. So the disc is removed from the what we call it, from the disc, from the big disc. So we put negative. Okay, not it is removed. And then the below also we do the same. Okay, it is removed, so you can put negative. Okay, then we times the distance. Okay, for the big disc, it lies on the origin, so that's mean 0. And for the small disc, okay, it's the distance of the center of mass from the origin is half r. Okay, can see or not, half r. Okay, then you solve. You solve and you get negative r per 6. Okay, negative r per 6. So this is the center of mass of the new disc after you cut it out. The small disc cut it out from the big disc. So where is it? It lies somewhere there. Can see or not? So it's negative, right? So means at the left side of the origin. Okay, of the Cartesian plane. Okay, so on the left side. That's why you get negative, negative r per 6. So r per 6 somewhere there. Okay or not? Actually, there is another method to use to find this, but we will learn this in the, what you call that, in the statics topic. Static topics. But we will use that method when we enter that topic. For right now, we use this formula, okay, to determine the center of mass of the disc here after the small disc is cut out from it. Okay. So I think for the next code, right, the third code. Cik Ngadon?
Dah.
Dah sudah.
I have given the yes. I have given after the advertisement just now.
Okay, so good. Okay, next we continue with the next question. Next question. Okay, so the next question, you are given a plate. Okay, this time we do different kind, different plate, different plate, L shape. Okay, L shape. So find the center of mass of the L-shaped plate below. So you are given, this is length 10 centimeter, 5 centimeter, 3, and here is 3. So that's mean the remainder of length here will be 2, will be 2. Okay, so what is the first step? If you can remember, it's the same step. We use from question 1 to question 6. Question 1 to question 6. Okay, so if you can write there in the text box, you can join the physics class today, can write there. Okay, so where is the Cartesian plane, the fixed point we choose? Okay, it's okay. Looks like they are still, maybe this topic is quite hard for them actually, this topic. Okay, we divide into 2. Okay, you can divide it into 2. So into 2 squares, into 2 rectangles. Okay, 2 rectangle. Okay, here and here. 2 rectangles, and the Cartesian plane you can choose anywhere. So I choose here. Okay, I choose here as a fixed point. And then, as usual, we find the center of mass for each of the object. For each of the object, we divide by 2 just now. We divide into 2 objects. So the first one, you draw the diagonal. Okay, then intersection of the 2 diagonal is the center of mass. Okay, so the coordinate will be, so let's check the coordinate. So here is 3. So that's mean in the middle of the 3 divide by 2, we get 1.5 for x coordinate. Okay, for the y coordinate will be, this is 3. So this is 10. 10 minus 3 is 3, right? 10 minus 3 is 7. Okay, 7. So that's mean divide by 2, we have 3.5 and plus this 3, so we get 6.5. Okay, so the y coordinate, okay, measured from the origin here is 6.5. Okay, if got any problem to understand, I still, I can help you all. Just write there in the chat box. Okay, 6.5, 3.5 in the middle here, then plus this 3, so you get 6.5. And we do the same for the box below here, the plate below here, rectangle plate below here. So the center of mass will be, okay, this is 5. So the x coordinate will be 2.5 and the y coordinate will be 1.5 because the 3 here divided by 2 is 1.5. Okay, that's the third step. Okay, so after you know the coordinate, now it's time to use the equation. Okay, so the equation, okay, hopefully until question 6, you all has memorized already the formula. So center of mass will be M1 x1 plus M2 x2 plus dot. So how many plates we have? 2 plates. So make sure you have 2 terms. Okay, so we have 2 terms here to be put here. So 2 terms because we have 2 plates. Okay, so we same thing. We use cross sectional area. So we don't use mass this time. Okay, do you understand why we don't use M? Because the 2 plates, rectangle plates is different. Is different. What you call that? Different size, different size, so it is understood it has different mass. Okay, not different. This is 7 by 3, this is 5 by 3, so it has different mass. So instead of using mass, you can use area. Okay, you can area again. Why? Because M is directly proportional to the area. Okay, M is directly proportional to area, so instead of using M, you can use area, cross-sectional area. So the area of the first top plate here is 7 times 3. Okay, the area of the below plate here is 5 times 3. So now we total the area at the denominator here, we total up the area. And the distance is the x distance, x coordinate 2.5, 1.5. This one is for the top plate, the top plate. So the other one is 7.5. So you get the answer 2, 2. So we do the same for y. Okay, so the coordinate will be 7.3. Same thing, because the 2 objects. So the area, the cross-sectional area, 7 times 3, 5 times 3. Then total the areas. Okay, now the distance here is distance from the fixed point of y from y coordinate. So for the top plate will be 6.5 and for the bottom plate will be 1.5. And you get the answer 4 centimeter. Okay, so where to mark? Where to mark? Mark must be logic. Must be logic. Where is the position? So you refer, this is 5. 5 horizontal, x-axis. So x-axis 2 cm, 5. So 2.5 is middle here. So somewhere there. 2. And then 4. So this is 4 is y, y-axis. So the height of the bottom block is 3, right? 3. So must a little bit high, 4 cm. Even though you are asked to sketch, but your sketch must be logic. Okay? Your sketch must be logic. So 3 cm here, so a little bit above 4 cm here. So this is 2 cm. So 2.5 in the middle of the bottom plate here. So must be less a little bit. So there is the center of mass of the L shape here. Okay, anak? So so that's all for the question for today. Actually, I prefer 5 questions only. So this question 6 is extra for you all, so that you become more understand for the what we've discussed today. So I give back the session today to Madam Nun.
Okay, Alhamdulillah, we have reached the end of today's session. Congratulations to those who can follow our session from beginning till the end. Before we end our session for today, I will announce the fourth or last digit code for credit claim. So the digit code is 6. Okay, the digit code is 6. So all of you, please stop posting your comment for a while, and if you haven't clicked the subscribe button, please do so. Make sure it turns to grey color. Okay, and activate the icon bell so that you will not miss the next class session. Then if you find that the lesson was beneficial, click like and share to your friends on your social media. Spread and share the goodness. Once complete, type done on the chat box before the certificate link is given as the token of thank you for your dedication in joining the free online class today. Okay, so the link of certificate and credit claim are already given, right, in the chat box. So the access code is #class_IU-EDD. Please take note, the link will end half an hour after this live. Make sure to use the EDD email only to log in. Okay, so incorrect email use will not be entertained. If you haven't got one, please apply. The link to apply the EDD email is also given in the chat box. If you wish to get more information on the online classes, go to the www.academyyoutuber.com, and to those who haven't joined EDD Junior Telegram, please do so. So once again, I would like to thank all students for joining our tuition class today. Remember that the more classes you join, the more credit you can claim. Okay? Feel free to share this free tuition class to your friends and teachers all over Malaysia. This is a collective effort from all the teachers throughout Malaysia for the students through the country. Thank you too for being a YouTuber Academy supporter too. Okay, I think that's all for now. See you in another session. Do not forget the hashtag bermula percuma, selamanya percuma. Stay safe till we meet again next time. Thank you and Assalamualaikum. Okay, bye.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.